Hello everyone, welcome back to our channel. Let's discuss the next named reaction, that is Bischler-Napieralski reaction. Let's see the statement. The cyclization of beta-aryl ethyl amides, commonly called as beta-aryl ethyl carbamates, into isoquinolines using dehydrating agent and oxidizing agent, commonly called as BN reaction. Right? So according to the statement, what we are observing, we are going to synthesize different kinds of the isoquinoline derivatives. To synthesize the isoquinoline derivatives, what are the reactants which we are using? The reactants are what? Beta-aryl ethyl amides. See this one. With respect to this amide, this is alpha carbon, this one is what? Beta carbon. The beta carbon is having aryl group. Right, that's why beta-aryl CH2 ethyl and amide moiety. So beta-aryl ethyl amide moiety involving in the cyclization phenomena by using an dehydrating agent and oxidizing agent. If you see this particular point, it is an example of intramolecular cyclization. It means the cyclization phenomena takes place within the molecule, within the same molecules we can say. So by taking a single reactant, we are going to synthesize isoquinoline derivatives. Here we are using two different agents. One is dehydrating agent, another one is the oxidizing agent. By using these two agents, we will have these kind of moieties, right? So let's see the mechanism. The mechanism is very simple. The reactant is what? Your beta-aryl ethylamide. The beta-aryl ethylamide. Here we have nitrogen atom. Nitrogen containing lone pair of electrons or not. These electrons will be involved in the mechanism. So what is the dehydrating agent we have used? POCl3. How can we write P double bond O Cl Cl Cl? See this one, what is happening? The lone pair electrons forming a pi bond here, thereby here the carbon valency is increasing or not. Thereby these pi bonding electrons move towards the oxygen. So oxygen will take the negative charge or not. This negative charge approaches to the phosphorus, thereby Cl will be removed in the form of Cl minus. Here we can observe the pi bond between carbon and the nitrogen. Nitrogen donated its lone pair electrons, means it will have positive charge or not. See this one, the positive charge. Okay. See the next situation. In order to remove this electron deficiency, what we are doing, we are transferring these pi bonding electrons towards the nitrogen. We are giving the minus charge and already plus is there, thereby the plus and minus will be neutralized. So what we are observing here, the nitrogen positive charge is going to be observed at the what? Carbon atom or not. So carbocation is formed here. This reaction is an example of what? Intramolecular cyclization or not. So because of that reason, what we are doing, we are transferring these pi bonding electrons towards the electron deficient center. Thereby what happens? A carbon-carbon bond will be formed between the ring carbon and the carbocation. See this one? The cyclization phenomena takes place or not. So finally we are coming up with what? Two rings or not. If you see the final moiety containing two rings or not. So here this moiety is having two rings. Now what happens? See this one. Because of these transfer of electrons towards this particular electron deficient center, the delocalization phenomena is disturbed here or not. The aromatic character of the benzene is disturbed or not. So in order to retain its aromatic character, what we are doing, we are removing a proton from this particular carbon, thereby it is going to form a pi bond. The aromatic character of the benzene remains same. Okay. Along with this, what we are doing, see this one, the nitrogen lone pair is donating its lone pair of electrons, thereby we are creating a pi bond here. Here the formation of pi bond takes place. At this carbon, valence is going to be increased or not. That's why these pi bonding electrons move towards the oxygen, the oxygen will take the negative charge, it can form a pi bond and it can remove the Cl minus. Thereby HCl will be removed and PO2Cl will be removed. So we are going to come up with what? This kind of moiety or not. Again, nitrogen containing positive charge, in order to neutralize the positive charge, what we are doing, we are removing hydrogen in the form of H plus, thereby we are giving the negative charge, the plus and minus will be neutralized. So we will come up with what? This kind of moiety. If you see the product is having one more pi bond or not, but in this case here it is a single bond. So in order to form a pi bond here, what we are doing? Oxidation. Oxidation means what? Addition of oxygen or removal of hydrogen. Here we are removing the hydrogen, thereby we are creating the pi bond here. So in this way we can transform the reactant into the corresponding isoquinoline derivatives by using this BN reaction. Okay, let's see applications. Here the R is replaced with what? Methyl group or not? Next one, the benzene is going to have a substitution, that is methoxy. At this position we are placing a substitution. Now the question is, how can we prepare beta aryl ethyl amides? We can prepare these kind of moieties by using this reaction. See this one, we have taken an amine. The amine is going to treated with what? Acid chloride in presence of a base. So in generally what happens, base can remove the acid or not. So the H and Cl removed in the form of HCl, thereby we will come up with the reactant. So in the competitive examinations, what happens, you may not directly get the reactant. The people may give these two reactants. From these two reactants we need to produce isoquinoline derivative. Okay, so for that purpose what happens, we have taken one amine. Amine is going to treated with what? Acetyl chloride in presence of a base. Then we are coming up with what? Beta aryl ethylamide. This one is subjected to BN reaction. These kind of products will be formed. If you see the numbering is starting from this carbon. So according to the numbering, what is the name of the compound? 7-methoxy 1-methyl isoquinoline. The another application is the amide which is connected to the heterocyclic ring, indole moiety. Here it is what? Simple benzene aromatic compound. This is indole, it is also aromatic compound. So to this we have connected the amide. That's why what happens, in case of the simple benzene, what is happening? Another benzene type ring is formed or not? So along with this 5-membered ring, what happens? We are going to introduce one 6-membered ring. See this 6-membered ring is introduced and the R is like this. So this is all about your BN reaction.